Greetings, Spartan fans. We are going to talk about graphs and inverse trig functions. So hopefully you got a packet from the sub. We're going to start with how do you find the inverse of a function? So hopefully you remember that to find the inverse of a function, we are going to switch x and y. So what I have here on the left is our parent sine curve. And for the parent sine curve, the domain is, for the parent, 0 to 2 pi, and the range is from -1 to 1. And then what I have for you on the right is I switched all the x and y values. So you'll notice that -pi/2 -1 became -1 -pi/2. Pi/2 1, switch x and y, became 1 pi/2. Pi 0, 0 pi. 3 pi/2 -1, -1 3 pi/2. So I switched x and y and you get this funky kind of graph. But there's something wrong with this graph. With this graph, it fails the vertical line test. So this really can't be a function. So something's definitely wrong here. Okay, so first notation, the inverse of the function is written as the inverse of x. That's not assigned to the -1 power. The -1 goes between the n and the x, and this is read as the inverse of the sine curve. Okay. This is a very funky graph. What I have drawn here is not the whole picture. If I start at the origin and I follow along my curve, so far we're so good. So far we passed the vertical line test. But the second that I start to curve around here, as soon as I start to curve around, I have failed. So the graph of the inverse function has to stop at the point 1 pi/2. But you'll notice, though, that if this is the point 1 right here, that only includes positive sine values. So the rest of my sine curve, inverse sine curve, comes down. And this, what I have here highlighted in green, is the inverse sine function. Its domain is from -1 to 1. So you switch domain and range. But the problem is that the range for the inverse sine curve is from -pi/2 to +pi/2. Between 0 and pi/2, that's all my positive values of sine. And from 0 to -pi/2, those are all my negative values for sine. Okay. All right, so for the cosine curve, the domain and range are a little bit different. So you'll notice that for the parent function, I graphed a little bit more, but here's the parent. And I switched x and y. So the point 0, 1 on the cosine graph is the point 1, 0 on the inverse graph. The point pi/2, 0 became 0 pi/2. The point 3 pi/2, 0 became 0, 3 pi/2, etc. So for the parent, so I graphed more than the parent, but the parent here is what I'm highlighting. The domain is from 0 to 2 pi, and my range is from -1 to 1. And then my inverse is noted as y equals the inverse sine of x. Oh, no, sorry, not sine, cosine. It should say cosine. And just like for the inverse sine curve, if I start on the x-axis, if I'm coming around and I'm going up the curve, I have to stop right here, because as soon as I start curving around further, I failed the vertical line test. So what I have highlighted in green is the cosine curve. Its domain is from -1 to 1, and its range is from 0 to pi. Okay. So if this is the point 0 pi over 2 right here, from 0 to pi over 2, those are my positive cosine values. And from pi over 2 to pi, those are going to be my negative cosine values. Okay. This is a little bit, I know it's a lot, it's pretty confusing. We'll do a lot of practice, and hopefully after a little bit of examples, it'll make a little bit more sense. Okay, here's tangent. So the tangent curve, I did the exact same thing. Negative pi over 2, 0 became 0, negative pi over 2. Pi over 2, 0 became 0, pi over 2. The domain of the tangent function is negative pi over 2, parentheses because it's not included, to positive pi over 2. And the range is all real numbers. And now we're going to swap that. The domain is going to be all real numbers. Notice that my curve is going all the way to the right and all the way to the left. And the cosine, inverse cosine curve is just one of these waves. And it's going to go from negative pi over 2 to positive pi over 2. And that's my range. Okay, so here we go. The big synopsis. So you're probably going to want to highlight this or do something for yourself. Here we go. Inverse sine. Here we go. So my inverse sine, the domain became -1 to 1. Included. And my range is negative pi over 2 to positive pi over 2. Inverse cosine, the domain is going to be -1 to 1. And my range is going to be from 0 to pi. And tangent, my domain is going to be all real numbers, inverse tangent. And my range is going to be negative pi over 2 to pi over 2. Okay, so for sine and cosine and tangent, we're going to take an angle as my input, and we're going to give out a ratio of side lengths. So for example, -√2 over 2, 0, 1/2, etc. And then for inverse, we're going to take the ratio and we're going to output an angle. It's all about knowing your unit circle. Okay, so we're going to do this next set of problems here, and we'll do the rest during the week. Okay, here we go. This means this, okay, you say this as the inverse sine of 1. That's how it's read. Don't say sine -1. This is read as the inverse sine of 1. And what I'm asking you is, what the question is here, what angle has a sine of 1? So you're working backwards. What angle has a sine of 1? That would be pi over 2. Okay, so same thing for the next one. What angle has a sine of √3 over 2? And we're going to stick with radians. So what angle has a sine of √3 over 2? But it has to be in our range. So there are a lot of angles that have a sine of √3 over 2. 60 degrees has a sine of √3 over 2. So does 120 degrees. If you look at your unit circle, which is the same as pi over 3 and 2 pi over 3. It cannot be 2 pi over 3. 2 pi over 3 falls outside of the range. The answer is only pi over 3. Okay. Who has a sine of negative root 2 over 2? So I'm going to go back to above here where I was giving you the domains and ranges. What might be very helpful for you is to know this. All positive angles, all positive inputs happen in quadrant 1. If you look at quadrant 1, all the angles are positive, and I have positive ratios, root 3 over 2, etc. So if I gave you a positive value for the sine, the cosine, the tangent, whatever, my answer has to be in quadrant 1. The real tough stuff comes when I give you negatives. So who has a sine of negative root 2 over 2? Okay, well, I know that it's a 45-degree reference angle. So if sine of negative root 2 over 2, I'm just going to draw it. Sine is y. By the way, that's drawing a proper triangle. Some of you didn't draw proper triangles on the test. So if you look at your unit circle, what angles have a sine of negative root 2 over 2 are, let's see, this would be 5 pi over 4 and 7 pi over 4, I believe. Neither one of those fall in my range. My range for sine is from negative pi over 2 to positive pi over 2. How am I going to get to this angle, 7 pi over 4? This all comes down to coterminal angles. How am I going to get to 7 pi over 4 going so that I'm in between 0 and negative pi over 2? 7 pi over 4 is coterminal to negative pi over 4. Those are coterminal angles. Negative pi over 4 falls within the range of the inverse sine, and that is my answer. Okay. The negatives are by far the hardest. We'll practice a lot. Okay, inverse cosine of negative root 2 over 2. So if you look at the range of the inverse cosine, the range of inverse cosine is from 0 to pi. I'm giving you a negative input. So who's got a cosine of negative root 2 over 2? Okay, well, cosine is x. In the second quadrant, it would be 3 pi over 4. And in the third quadrant, it would be 5 pi over 4. Only one of those falls within the range of 0 to pi. And the only one of those that falls in the range of 0 to pi is 3 pi over 4. I wasn't kidding when I told you that we were going to be doing unit circle for months. Okay, let's keep on trucking. So the inverse cosine of negative root 3 over 2. So let's figure out our what angle has a cosine of negative root 3 over 2. So that's going to be cosine of negative root 3 over 2 is 30 degrees. And so it's going to be a 30-degree reference, or pi over 6. So if you look at your unit circle, negative root 3 over 2, it's going to be either 5 pi over 6 in quadrant 2 or 7 pi over 6 in quadrant 3. But only 5 pi over 6 falls within the range of 0 to pi. Okay. Inverse cosine of 0. Okay, inverse cosine of 0. Cosine is x, so this is the point 1, 0, 0, 1, etc. So this is going to be, who has a cosine, an x value of 0, that's going to be 90 degrees, or pi over 2. Okay. Inverse tangent of 1. Okay. The only way to get a tangent of 1 is if the x and the y values are the same. Divide anything by itself, like x over x is 1, y over y is 1. So in order to get 1, I have to have the same x, the same numerator and denominator. Okay, so for a tangent of 1, root 2 over 2 over root 2 over 2. Which means that my x value needs to be root 2 over 2, and my y value needs to be root 2 over 2. And that's going to be 45 degrees. I gave you a positive value. Your output is going to be in quadrant 1. Positive input, positive output. So if we go back for a second, I gave you a positive input of 1, you gave me a positive output. Positive input of root 3 over 2, positive output. 0 is neither positive nor negative. And so for the tangent of 1, positive input, positive output. The problem becomes the negatives. Which function am I talking about? If I'm talking about a sine function, negative input, negative output. If I'm talking about a cosine function, then it's totally different. Okay, so the tangent, I want inverse tangent of negative root 3. The range of tangent is from negative pi over 2 to positive pi over 2. I think it's helpful if you look at that on a coordinate plane. Here's negative pi over 2. Here's positive pi over 2. Okay, so that's going to be quadrant 1 and 4. Positive input's going to be in quadrant 1. Negative input's going to be in quadrant 4. So now you got to figure out when you divide sine over cosine, how am I going to end up with negative root 3? So I want my sine and my cosine to end up being negative root 3. It's the same thing as negative root 3 over 1. You got to play around with it. But who has a sine of negative root 3? Well, no one does. But I do know root 3 over 2. That I kind of recognize. And I do know 1/2. And so when you reduce these, you end up with negative 3 over 1. So who's got a sine of negative root 3 over 2 is 60 degrees. So that's going to be pi over 3. But I want my answer to be in quadrant 4. That's going to be negative pi over 3. Okay. What the heck is the tangent of infinity? Like, never seen that before. Okay. The tangent of infinity is an asymptote. It is the equivalent of undefined. When I'm asking you who has a tangent that's of infinity, I'm asking you, where is it undefined? Okay, well, if you look at the graph, the tangent is undefined at negative pi over 2 and positive pi over 2. So my answer, both of those fall within the range, so either one of them would be acceptable. Either negative pi over 2 or positive pi over 2. You only need to give one. If you give both, you won't get it marked wrong. You could give either one or the other. Okay. The homework is written on the sideboard. It's also on Google Classroom. I should be back tomorrow.